Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about, do you need an oscilloscope, yes or no? So let's dive deep into it. So what the heck is oscilloscope? Well, basically, if this took some dimensions to it, it will become oscilloscope. So whenever you are talking about this sort of meter, all it will do is just do one resolution. Basically, you point it, it gives you a number, the end, go home, sweet dreams. Or at best case scenario, if it's a AC meter, like this is designed for AC, means if you use the probes, it will be like, hey, it has this much, basically averaging RMS, that's it, done. It only gives you one rating out of it. So basically it has no temporal resolution. It can give you the latitude but cannot give you temporal data, meaning what's happening to the signal. So temporal resolution, meaning what's happening throughout time, that is unknown. So oscilloscope has that dimensions. It still only measures voltage. Now be mindful, realistically the only thing, everything that you measure is just resistance, is basically voltage only. So and you're like, how the heck you measure current? Voltage drop. You only measure voltage. So voltage meter, if it had temporal resolution, will become oscilloscope. So to make this job easier, we start with a sampling system. Basically, whenever you buy a meter, it will have a circuit that we call analog to digital converter. Basically, you connect the probe, the signal, as in the actual probe points data, as in the energy, goes to the analog to digital converter, and digital converter is like, okay, this level voltage goes to this value, digital value. So we call it analog to digital converter. Now analog to digital converter have a bit depth, how much resolution it has from 0 to maximum. Basically 0 is, let's just say 0 volt, and maximum is 10 volts. How much slicing it can give you. So how many steps you have from 0 to 10. So we have 8-bit, that is good resolution. Be mindful, multimeters do not go that high. Unless you are talking about benchtop industrial grade multimeter, those puppy go bonkers level. But generally you will not even get 8. Then you have 10, then you have 12, 14 bits. So those things define how much slicing you are doing in the amplitude direction. So that gives you the bit depth of analog to digital converter. That's the first margin, the x-axis. Then you have y-axis. It can trace it at high speed. This is the difference between a multimeter and an oscilloscope. That tracing fact, because it's taking measurements so quickly that it's tracing a real path, like how the heck voltage is following, like the voltage path, so to say. And that's the whole point. And we call it times second, how many times per second is doing. Now nowadays digital oscilloscopes are so fast, so ludicrously fast, that it has measuring units in gigasamples. 1 gigasamples per second. Now be mindful, you can buy a new modern meters that exceed that 1 gigasample. Some are going as high as 3 gigasample. Now you're like, okay, what does that mean? That number is too weird. Gigasample, we don't know. Well, think in this way, you are noting down a value every nanosecond. Let that sink in. You take a second, you stretch it to nanoseconds, nanosecond number 1, nanosecond number 2, nanosecond number 3. That's how fast you are doing. It's in nanosecond, not in millisecond, nanoseconds. So this puppy is fast. So x-axis, that is your bit depth, that's also good. Y-axis, that's the main butter. The fact of the temporal resolution comes from sample per second. And be mindful, the sample per second does not mean your bandwidth. Sample per second, because be mindful, if you are plotting something very quickly, then only you can see an image appearing. Basically, oh, the signal is like this, then signal goes like this, then signal goes like this, then it goes like this. The square wave, let's just say. But if your sampling is low, the bandwidth that you can observe clearly would be also lower. So this number is always the bigger compared to your bandwidth. That's why, like, it's not a fake, it's not trickery. It has to be like this. People who deal with audio sampling, they will tell you, it's like, if human voice goes up to, let's say, 20 kilohertz, you cannot use 20 kilohertz to store human voice. You would need 44.1 kilohertz. So same way, they have to double the sample. Same here. Now here double, you need far more than that. So 1 gigasample does not mean, oh, I can give you 1 gigahertz of bandwidth. So bandwidth allows you to see clearly, basically, how the signal is rising. We say signal, like digital signal or processing signal, whatever have you. They never have absolute 90 degrees. They always have a behavior to it, how quickly they are ramping up, how they are falling down. This behavior defines whether your system is working or not. For example, if you have watched Linus Tech Tips HDMI cable tester, why the heck that equipment was so expensive? Because it was seeing the voltage rise and falling. And if the signal was reaching a sloppy point where it's no longer clear, the receiver on the other end was like, bro, I cannot make sense of it. So that's why bandwidth allows you to see it clearly, how it's happening or not. Because instruments, basically this TV, this monitor, this everything, all that, they are not designed to see inside that. They are just designed, I'm receiving a bit, yes or no. So to see inside that, hey, why are you not seeing the signal clearly? You need oscilloscope. You need far more sampling. You need to be exponentially higher than what's happening there. Then you can see clearly what's actually happening. Now, signal and rise and fall times, that's the key ingredients here. And here's the deal. When you're talking about a very cheap oscilloscope, you're talking in kilohertz. When you're talking about medium scopes right nowadays, you're talking at least few megahertz, or 10, 50 megahertz is possible. The moment you touch gigahertz, basically the oscilloscope that are used by Intel, the oscilloscope used by Qualcomm, yeah, those puppies are so expensive. They do not even have a price in their websites. They have get quotes. And if you think that's expensive, let me give you context. Universities will go bankrupt if they try to buy it. The modern scopes that can touch 10 gigahertz, you do not want to see the price. It's custom order thing. It will make Ferrari look like, that's chump change. That's chump change. So be mindful. And if you ever had confusion between what's the difference between analog signal and digital signal, the simplest way of understanding is like, think of this. Like if you have a torch that you turn it on, it slowly ramps up, slowly turns off, and then you have a digital torch that's like on, off, on, off, on, off, clear, distinct data signal. That's what we mean by digital. Analog, it has a range. It goes up and down, like, AM and FM kind of scenarios, like going up and down. And digital, you do not have to worry about going up and down. However, digital come with the penalty of speed. You need to be ludicrously fast. You gotta ludicrously fast. So oscilloscopes become very expensive. And be mindful, the tool generally proceeds technological development. We built early oscilloscopes for radio communication and radars and all that jazz. Those allowed us to build better electronics. Those allowed us to build television. Television allowed us to make better CRT oscilloscope. That allowed us to go even further and further. And now we have cheap oscilloscopes that will be like, if we ever had a time machine and send it back to, let's say, World War II, and end of World War II, they're like, what black magic is this? How it can be this fast? So this is the whole point of oscilloscope. So why the heck do you need temporal resolution here? Well, reality is everything. For example, let's say AC to DC converters. DC to DC converters, all of them, what are they doing? On a fundamental level, like if you go to the deepest essence of it, what the heck it's doing? It's doing high-speed silicon switching. Basically, it has a semiconductor that is turning on and off as quickly as possible or as quickly as needed. Like sometimes kilohertz, it would be doing something like that, or sometimes megahertz, it would be going bonkers fast. So that's it. But how would you see it if you do not have a way of measuring? Because if you put a multimeter, all you're gonna see is an averaged value. It's not good enough. You're not gonna see how the rise is happening, when the switch is reaching stabilization, how much is overshooting, how much is undershooting. You will not see it. You will just, okay, there's an average value, but you do not have the data, what's exactly happening inside. So high-speed power electronics basically needs it. Then we have all digital communication. So whenever you're talking about digital, like this video signal that is receiving, that video file, that is, what is it? It's digital. How would you see it? Because again, inherently digital signal should be like this, basically on and off, on and off. Of course, this is a PWM signal modification, but same concepts. So digital communication requires high speed, and it requires you to clearly see, okay, the signal is going up and down. Now be mindful, the instruments, the producer instruments and receiver instruments, they are designed just to assume it works. They assume their electrical engineer did their job properly and the signal they are sending is properly under spec. And the receiver is like, I'm assuming the signal they are sending is properly under spec, and then I'm just going to work based on that. But when you put an oscilloscope, you can see some odd behaviors, like, hey, there is a little bit of offshoot, hey, there is a little bit of undershoot. Now again, if it's a sensitive equipment, you may be like, yeah, we gotta fix this, or it may be like, who cares? And this is another reason why we need this now more than we need it in past. In past, we used to use a lot of analog electronics. Those puppies were resilient. When you're talking about digital electronics, it gives you speed, but comes with a consequence of fragility. So this puppy is fragile AF. So you need like absolutely damn sure like how things work. So digital communication requires very high speed, and all motor drivers, like for example, if you see stepper motors and BLDC motor, they are controlled by PWM signal. How would you know your signal generator is not working or versus your motor driver not working? Unless you can see the signal itself is like, hey, signal is going, but my motor is not turning. That means somewhere either the motor driver is broken or the motor itself, there is some faulty wiring and all that. So how would you see it unless you can see the signal clearly? And every single, like you buy BLDC motor now, it has a ludicrously complex waveform, and if you cannot see it, you will not know why it's working or why it's not working. For example, the waveform of three BLDC motors are generally almost like a three-phase, but if you noticed your Ender 3 stepper motors, they work, everything is fine, but they are noisy. And there is this magic board known as silent board. You put it in and it's like, everything is quiet. How the heck that happened? How the heck it became silent? Same hardware, same load, how the heck it became silent? The waveform, if you see it side by side on an oscilloscope, you'll be like, I see it now. That's why you need this temporal resolution for modern world. Old world, yeah, you can get by without it, but modern world, you need it. So this is why. And then you come to, that's the manufacturing side of it, you're building something. But there is an aspect of it we call ghost hunting, meaning if you have electronics that's not working, you need this also. Because no electrical circuit is perfect. Back in the days, they were resilient enough, so like, who cares? Now we need it as close to perfect as possible. Now, fundamentally, law of physics does not allow it. So whenever you see a schematic, it's classified as simplified schematics because, oh, you're like, oh, there is this one lead or there's this one lead. You're like, dude, on circuit board, it will be close to something else. Maybe it's picking up RF noise. It may be picking up switching noise. God help you, it's capacitively coupling itself to something else. You're like, what the hell? Yeah, that's the difference between thinking that it works versus, okay, that's why it does not work in real life. So no circuit is perfect. Let that be very clear. It does not matter who builds it. No circuit is perfect. And law of physics prohibits it from becoming ever perfect. You can just get it good enough. So there will always be noise, there will always be ghosts, things that you do not see in like normal day-to-day operation, but it could be having an effect. Now, is there an effect on us, basically like as a user? Is there effect? Yes, absolutely. At best case scenario, it will harm the lifespan. For example, especially laser diodes, those puppies are sensitive AF. So if you're running a, let's say, fiber laser cutting business and the power supply is just a little bit dirty, yeah, your laser that's supposed to run for 5 years would be like, yeah, 3 years, I'm out. You will be like, hey, I bought this LED that it has Cree LEDs, it's supposed to run 10,000 hours, you run it for like 1,000, it's like, bye. What the hell? That's the whole point. Where is that happening? Because on paper, if it was wrong, it would not have worked, but you would have to see in temporal dimension what the hell is exactly happening. You're like, okay, for example, this individual got a dumpster diving and found a regulated DC power supply, linear power supply. Very good, very happy, and he did it. Now he had an oscilloscope, so he connected it. Now here's the oscilloscope, you connect something, load it up, measure with multimeter, that's what most people can do. But if you connect to oscilloscope, you can see things. What kind of things? This oscilloscope has a surge shock, meaning you turn it off, it gives a spike. So when you are running it on 5 volts, it's like 5 volt, good, stable electricity, use it. But let's say you are running an Arduino on it and everything is fine, everything is dandy, and you're like, hey, let me turn it off. You turn it off, it fries your Arduino. Why? Because during turning off, it gave a surge. And that surge is so quick that it's very unlikely that it will be picked up by any sort of multimeter. But it will fry your devices. So it's one of those things. Like this is a digital signal which again it's not perfectly coupled. You can see like it's coupling if is not happening properly. So it's like either overshooting or undershooting. You have to tune it. Same happens in actual hardware wiring also. You have to tune everything perfectly. If you do not see it, how the heck you gonna tune it? Like this is example of Chinesium power supply, and you can see that like this power supply claims 10 amp power rating. Here's the deal, this individual only loaded up with her power resistor to 3 amps, and you can see that like it's slowly becoming like, it's becoming like this. What the hell? Basically, it's oscillating. It's not able to sustain it properly. This is the difference between a Chinesium power supply that is like for 5 rupees, like, you know, for $1 we can give 1 kilowatt of power. It's like, no, you can't. You hope it works. And you hope the individual on the other end does not have oscilloscope. Because if they see this, if they connected this sort of system for any expensive optics equipment, expensive LEDs or laser diodes or God forbid, analog audio circuitry, yeah, that would be fried. Poof, gone. Done. So for that reason, you have to understand it. At best, it will reduce your lifespan because again, it will erode the hardware, like physically harm it by overvolting it or undervolting it, and over time, it will go away. And again, imagine it like how would you detect this system is the one that's frying your Arduinos unless you have oscilloscope? Of course, you will figure it out eventually after frying 2 or 3 Arduinos. Like maybe the power supply is broken. That's how many people do, but you see why it's not cost effective. After 1 or 2 frying, you will be like, you know what, oscilloscope is free. So that's why we need to trace it. We need to spend time finding it. We have to fix it. So that's why ghost hunting requires. That's why it's like so many repairmen, they have oscilloscopes. So this is the ghost hunting side of things. Now, let this be very clear. While we can see electro boom going boom boom with basically oscilloscopes, he is the individual whose electricity is scared of them. Basically, electricity is like, I cannot touch this guy. Now, you and I, we are not that guy. We are not that guy. Okay, electricity is gonna make love to us and we're gonna go poof. So he makes electronics go poof, electronics will make us go poof. So be very mindful. This is not a joke. When I'm talking about electronics of this caliber, we are talking about something serious. It's a serious tool, and mistakes at best case scenario will have minor consequences like your electronics frying, and worst case scenario, you going up. And yes, it has happened. So trust me when I say this. He's immune to electricity. You and I are not. So let's say this looks fun and all, but if it happens to you and you're not ready for it, or like you're not, of course, who wouldn't be ready for it? Because yeah, you're not trying to fry your own system. So yeah, bad things happen. So trust me, it's serious, significant. And if you are an individual who's dealing with high voltage DC, God help you. If you're an individual who's dealing with motor drivers and power electronics, you have to be very serious here. Special precautions have to be done. Heck, even in low voltage, you could fry your system if it's connected to USB. As long as it's battery power, both things are battery power, you good. The moment something gets connected to ground, you have to be exponentially careful. You have to take special precautions. And AC means under no circumstances should be taken, yeah, I'm just going to connect the probe. At best, you're going to fry something. At worst, you're going to boom yourself out of existence. So let that be very clear. So how do you do proper AC means without doing this? Well, you have to buy things like this. Yes, let this be very clear. These puppies are expensive because they are active electronics, but they are designed to work. For example, you can see like they start, the voltage range is 1000 to 10,000 volt. Sometimes, meaning if you're dealing with substation level electronics, they can still work. And they are designed for that. Basically, they will feel safe. If something oops happened, it will go poof rather than taking you with it. And these are the cheap variants. There are some expensive ones which are designed with much higher grade insulation so it can handle high DC offset voltage like 1500 volt DC. Like who the heck works with 1500 volt DC? Come to solar panels. Solar panels nowadays, a string voltage can easily reach at that point. So if you need to see something like that, yeah, do not just use your oscilloscope and like go like this. Yeah, that may be the last thing you do. So trust me, you are not electro boom. You will go boom. So for that reason, use these things. They will go boom rather than you going boom. So, and if you ever noticed how the heck Fluke handheld oscilloscope is so goddamn expensive, yes, they designed it to their best ability to make sure that it never takes you with it. It will go boom, it will not take you boom. It's ludicrously well engineered. They know that somebody is going to do idiotic thing with it. They're like, we know we're going to do something bad with it. We have to just cover our asses with it. I'm pretty sure half of the price is just for liability coverages. So it's very brutal issue because ground loops are a big issue. We do not think about it, ground loops, unless you are an audio engineer. Audio engineers, they talk and breathe ground loops, but for normal people, you and me, we do not talk about it. And it's a very big issue. If I'm working with Arduino and Arduino is connected with USB, with my computer, the computer has grounded it, meaning there is actual ground. So if my oscilloscope is also grounded, now I have risk. Meaning at best case scenario, I'll fry the system, but because of the energy of the system, most likely it will shut off safely, hopefully. Worst case scenario, I will fry some electronics. Really worst case scenario, I could create a very low impedance path between mains and neutral. God help you then. So let that be very clear. While this is fun and games, oscilloscope and all that, this is not fun. You could go boom. So question becomes what to buy. Well, let this be very clear. It is expensive. I bought this puppy and I thought this was the most expensive thing I'm gonna. Why this is so expensive? Well, because this does AC and DC clamp meeting. Meaning I can put a battery terminal into this and still read it because it has Hall effect. I thought this was expensive. I look at the oscilloscope price now. This is free, man. Who cares? So yes. Let this be very clear. It is expensive. I am not blind to the fact that it's expensive. And yes, you can still learn a lot of electronics. Heck, you can get quite far, especially in ham radio ecosystem. You're gonna go places. And those people are like, no, we will never touch oscilloscope. Those people who can go places. Audio people, they're gonna go places. So you can go quite far without this system. Let that be very clear. However, in modern world, in digital era, you will be limiting yourself. Because be mindful, those little power spike things, those things could be so short that you may not see it easily. So you will be giving yourself some handicap. Again, for starting out, just learning things, not a problem. But if you want to be a professional in it, and you, or even as a hobbyist, you want to like, hey, I want to get really deep into it, you may be like, I just have to buy it. So it's one of those things. It's like, I understand it's expensive, but like if you really need to go deep into electronics, sooner or later you'll be like, just shut up, take money. Now, there are some very cheap options which gives you enticement that you can buy it for like almost the same price as this. You can buy like DIY units that are like this. They are very cheap, like 3,000 to 4,000 rupees, and like, you know, $10, $20 sometimes. Now, could you use them? Well, no. They are very hard to use. They are very fiddly. They are designed, there is a philosophy in cost cutting. We call like, you know, cost reasonably. If you cut it too much, you may make your product useless. These are too close to useless level, meaning you on paper everything is there, but in terms of usability, you'll be like, dude, this is hard to use. Like hard to use, like it will be difficult. So the moment your initial curiosity wears off, there is a very good chance you're gonna forget about this, or you just eat this puppy. So unless if you really only can buy this, I would urge you only to buy that if you have a lot of patience. I mean, you have to be God level patient. You have to be like Buddha level patient, because again, it's fun thing to see some YouTubers going tick 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 on this. It's another thing to do, rely your livelihood on that. So that's a very different thing. Fun thing to start, fun thing to just, you know, tinker around, but like, oh, this is my tool, I'm relying on it. Yeah. So these things are way to cut cost down. So I would not advise you to go into this. Then we have some middle option. The middle option is the cheap handheld option. Now these are very weird because they come in very varying range of quality. Some are good, some are really good, some are like some are like, what the hell is this? So they are a bit weird. Now, first line of defense that you must have is that buy it from a brand that you see way too many reviews of. If you see only one review, run. So flat out buy from something that you have seen reviews, you may have seen a teardown, may have seen deep dives on into it. Only then trust it, and do not trust any brand new models. They do not have very good QC. So they could literally release one model which has fatal flaw, and you'll be like, ouch. While they are expensive, they do not come with return policy. So be mindful, be thorough with your research when you are trying to buy them. And you can get some really good stuff, like really good. And these are generally half price. So a quality instrument would be like, let's say $20,000 to $30,000 rupees. This puppy will be half of that. Again, they also go to very expensive range, but generally assume half the price. Now be mindful, I have seen some companies designing it quite well. Even this brand, Handtech, have designed something quite good. Like some of the oscilloscopes are good, not god tier, but good. And they have one of my personal favorite feature, they have data logging, meaning they have USB port, because again, they use this sort of cell as for power charging. They have two of these puppy to provide power to them, and they have USB-C for charging. But somebody thought of like, hey, we are putting USB-C port, might as well put data port there, serial to USB converter. And yes, you can run a computer-based system. Now, does that help? Yes. That's like, shut up, take money. Flat out, you can show, like if you are having oscillation in your circuits, you can show it to your teacher. It's like, hey, this is the screenshot, this is the oscillation I'm having. You are measuring capacitors. Capacitors behave differently based on the temperature. You can show it. It's like, hey, this was the ambient temperature, I recorded it, and you can see the curves. So flat out, it does allow you to save CSV. Now, if you're buying any no brand system which has this sort of USB output, please make sure that you have seen where to download that file, where to run the file, and is it Chinesium, or like have somebody actually spent time converting it. So they are weird, but they have some good options as long as you can spend time researching them. Then we come to the cool aspect of classic scopes, like just scope, like scope, like you do not think too much about it, scope. So they are the best, let that be very clear. While you can get something like this, while these things, some of them are like very high end, quote unquote, these are like what we call the daddy. This is like, we do not talk about this. If you buy this and you have issue, there is a good chance this is not faulty, you are faulty. So classics are the best. So what options do you have? Well, you can go into old model, like for example, Rigol DH0804 is the new model. That means there is one model that is behind it that is a bit cheaper now, and it's available in sales. So you may go into older model, and heck, there is an older model even before that. But that goes a bit too old, but you can buy that. If you have nothing, hey, that will work. So you can go into old model, you can go into second hand. These devices are very long lasting devices unless somebody tampers with it. They still hold their value in second hand also. And this Oscilloscope DHO80814. This is my dream puppy at this point in time. Why? Well, this has 4 channel. I need 4 channel. Why? Well, BLDC motor, at the moment I'm going to touch it, that puppy has 3 channel consumed. So I need 2 channels is too little for me. So I need 4 channels. And again, SPI communication also requires 4 channels. So 4 channel. It has 70 megahertz. That's not an issue. First, normally that's not an issue. Another time some people can say they can hack it, so that's not an issue. The hardware is the same. It is 12-bit, that is very high resolution, so I do not have to worry about it. The price 50,000 rupees. I used to think this was expensive. This is free. So yeah, it is what it is, but it is what it is. Like, I'm jumping into electronics, and the project that I have talked about is slowly chipping away at in the background and starting to get some results. So that's the guide for it. It's like, try to be away from this. If you are trying to buy this, please be damn thorough about all the aspects, and there is a reason why these things exist. So you can buy them. Again, I know the painful cost of it, but think of it this way, like, there are some things that as you get older you understand that cheap things are cheap for a reason. So this was my presentation on oscilloscopes. Do you need it or not? Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.